Hi and Assalamualaikum. I'm Aisyah Hazirah. Today, me and my group member will be presenting our project application titled Browser History Management. So, browsing history is one of the most essential features of a web browser. It allows users to conveniently revisit previous pages and navigate forward after going back. The main goal of this application is to provide systems that manage this navigation efficiently and accurately, just like modern browsers. Here are the key features of the browser history management system. The first one is it allows users to visit new web pages and add them to their browsing history. Second, users can navigate back to previously visited pages using a backstack. Third, if they go back, they can also move forward to the pages they were on before by utilizing a forward stack. So how it works? This application utilizes two stacks. The first one is the backstack, which stores all the previously visited pages so users can navigate back. And the second one is the forward stack, which temporarily stores pages after the user navigate back. This stack-based approach ensures that history management is efficient and well-structured.
Bismillah. Assalamualaikum warahmatullahi wabarakatuh. My name is Hanif, Zakwan, binti Anuar, and I'll be explaining on question number 2, which is on how does the application work. Okay, so without any delay, let's get into it. So for the first part, I'll be explaining on application operation, or we know as the methods that are inside this program. So the methods are visit page URL, go forward, go back, and exit. Alright, so these are the 4 methods that is going to be used inside this program, and I'll be explaining it later inside the demo. So I'm not going to waste any much time here. Okay, so now for the data organization and storage. Okay, so the question right now is, why do we use stack? Okay, why do we use stack? The browser history management is more to a navigation system where you navigate between pages, which makes it ideal for stack, because stack is a last in first out data structure, making it ideal for navigation, managing sequential navigation. So it's the ideal data structure to be used inside this program. Okay, next I'll be explaining on the storage pattern, which is it consists of 2, the backstack and the forward stack, which the backstack stores pages in reverse order of navigation, and users push pop efficiently, while for forward stack, it stores pages navigated forward after going back, and pushes and pops operations similarly. Okay, so right now I'll be starting the illustration and demo. So before I start, I'll be showing you the components that I'll be using inside this illustration. Okay, so there'll be 4: the backstack, the front stack, the display and current page, and the pages that I'll be using. So to make it simple, I'll be just using A, B, C, D as the pages, just to make it easier to understand. Alright, so now let's take an example if we want to visit page A. So the method for visiting page A is visit page URL. So the algorithm for visit page URL is right here. Okay, so I'll be explaining on that. So if the current page is not null, okay, let's just see. The current page is null. So we're gonna set the current page to the new URL, clear the forward stack, and print the visitor page. Okay, so it's just gonna be simple. We're gonna set page A right here as the current page because the current page is empty. Okay, so let's do that. Okay, as you can see right here, A, the page that is visited, we're going to set as the current page, and it's set just like that. Okay, now let's take another example. For example, we're going to visit page B. We're going to use the same method, and the algorithm for it is just as same. But let's see if the current page is not null. So as you can see right here, the current page is filled with something. So it's not null. So we have to push the current page, which is A right here, onto the backstack, and set the current page to the new URL, which is B right here. We're going to set as the current page, and A is going to be pushed onto the stack. Okay, so let's just do that. Okay, so now B is set as current page, and A is already pushed onto the backstack. So that's pretty much about it if you want to visit a new page when the current page is filled with another page. Okay, now let's take another example. If we want to go back, now we are at the page B, we want to go back to page A. Okay, so the algorithm for go back is if the backstack is not empty, as for the condition right now, the backstack is not empty. We have to push the current page, which is B right here, onto the forward stack, and pop the top page from the backstack right here, and set it as the current page. So the B right here, it will be pushed onto the forward stack, and A, it will be popped and set as the current page. Alright, okay, so let's do that. So as you can see right here, B is already pushed onto the forward stack, and A is popped off from the backstack, and it will be set onto the current page. Okay, so A is already set as the current page, and B is already in the forward stack. Alright, right now, what if we want to go forward? Like for example, we are at page A, we want to go back to page B. So how do we go back is using the algorithm right here. So it's just as simple, it's just as the same as if we want to go back, but it's just using the different stack right here. Like if you want to go back, we use the back stack right here. If we want to go forward, we use the forward stack. Okay, so right now we're going forward. If you want to go forward, A right here, it will be pushed onto the backstack. And the B, it will be popped and placed onto the current page. Okay, so let's do that. We just read the algorithm, push the current page onto the back stack, pop the top page from the forward stack right here, and set it as current page because we want to go forward. Okay, so now let's do it. A is pushed onto the back stack, and B is popped from the forward stack, and it will be set as the current page. Okay, and that's pretty much about it. So we have covered on going back, going forward, and that's pretty much it. Thank you very much.
Assalamualaikum, hello everyone. I will continue on presenting the algorithm. This is recording, and the method that we will choose is visiting page. This is pseudocode for it. Now let's move forward. We have 3 operations to execute. You can see first operation is push operation. It's just execute one operation at one time. So it will give you time complexities of big of 1. And next we have set operation. It also give execute one thing of one time. It will give you time complexity of big of 1. And then we have clear operation. This is up to the time. It's up to the page. It sometimes give you, it will execute one at one time, or it will loop at one time. So it will give you either b of n or b of 1. Next, we will find the overall time complexity. As you can see, we have 3 operations: b of 1, and b of n. Then we summarize the b of 1 plus b of 1 plus b of n. But consider it, the loop is dominate the operation, so we will get b of n. So average case consideration, we will get b of 1, but sometimes we will get b of n. Because the loop in clear operation will dominate the operation. Next, for the conclusion, we have worst case and average case. Worst case is b of n because the clear operation will execute in loop, but in average case we will have b of n because we will usually visiting at the page after in forward stack is 0 or 1, 0 or none. Yeah. In summary, using the stack for managing the browser history allow for efficiency page navigation. The worst case, the time complexity is b of n due to clearing the forward stack, but the average case is b of 1, making the visiting page operation responsive and suitable for real-time application like web browser. This design ensures efficient, balanced performance and user experience. Thank you. That's all for me.
Assalamualaikum. My name is Afiqah Zakirah. Next, I will show you the output when we run the code. When we run the code, first we need to visit a page. For example, we visit youtube.com. Next, we visit x.com. Now, we are at x.com. If we go back, we will go back to youtube.com. And if we go forward, we will return back to x.com. Next, we move on to the classes, interfaces, and operation implemented in the code. First, the classes used in the code. The first one is java.util.scanner. The scanner class is used to get user input, and it is found in the java.util package. In order to use this, we need to create object of the class. Next, java.util.stack. The stack class provides functionality specifically for stack data structure operations. The stack class represents a last in first out stack of objects. It extends class vector with 5 operations that allow a vector to be treated as a stack. There are no interface used in the code. Next, we move to the operations used in the code. The first one, from java.util.scanner class. First, in order to use this, we need to create the object. The operations used is the next line operation. This operation advances this scanner past the current line and returns the input that was kept. Next, the close operation. This operation usually is used at the end of the code to close the scanner. Next, from java.util.stack class, the first operation used is the push operation. This operation push an item on top of the stack. And then pop operation. This operation remove the object at the top of the stack and return that object as the value of this function. Moving on to java.util.vector class. The operation used is clear, which removes all of the element from the vector. Next is the operation isEmpty, which is used to check if there are elements in the vector. It will return true if this vector contains no element. The method clear and isEmpty is used by the object created in the stack class, but it is inherited from the class java.util.vector.
To conclude, the browser history management system is designed to efficiently simulate a web browser's history navigation. It utilizes 2 key components. The first one is the backstack, which stores previously visited pages, and the forward stack, which allows users to move forward to pages in the forward history. By leveraging the last in and first out behavior of stacks, the system ensures logical, seamless transition between pages. This structured approach provides efficient performance, achieving worst case in complexity of big O notation, which means time it takes for the algorithm to complete increases linearly, and an average case time complexity of constant time. To sum up, the browser history management system operates with 3 core functions. The first one is visiting a page at the current page to the back stack. Second, navigating back pushes the current page to the forward stack. Finally, moving forward pushes the current page back to the back stack, ensuring seamless transitions. This system is practical example of stack usage in a real-world application. It highlights how essential data structure operation like push and pop fulfill the application functionality. Moreover, it achieves stack efficiency by adhering to the last in and first out principle, ensuring logical navigation and efficient handling of browsing history. So that's all from our group, and thank you for your time and attention.